So here is the problem statement. Given a binary tree, find if it is height balanced or not. A tree is height balanced if difference between the heights of the left and right subtree is not more than 1 for all nodes of the tree. So let's understand what is the difference. What is balanced tree? Uh, so here on the one notepad we have uh, two trees. One is height balanced and another is not balanced. So let's understand this. So if we consider this as a tree, subtree of this tree, so its height is 1. So it is balanced. For this we consider, so its height is 0 and its left height is 1 and right height is 0. So the difference is 1. No problem. When come to the 39 node, so its left height is 0, right height 0, so difference is also 0. And when comes to this point for one root node of the tree, left height is 2 and the right height is 1. So the difference between this is 1. Uh, so that's why, because each of the node have the left and right subtree's length, difference is 1 or less than 1. So if we think about this solution, this unbalanced tree, so 5 has left and right subtree as 0 length, 0 and 0. For 10, its left subtree is 1 and right subtree is 0. So the difference is becomes 1. And now comes to the point 1, no root node of the tree. Now the left subtree has height 2, where the right subtree has length 0. That means 2 minus 0 equal to 2. That is greater than 1. So that means it is an unbalanced binary tree. So we know that how to find the height of a binary tree. No, or not, you can see the video on clicking the I button on the description. You will get the link of that video in the description box. Okay, so let's try to understand the problem. So what we can do, if we are getting like left height is L and the right height is R. So if we find the difference between these two, so the difference between these two is greater than, then we will do flag is equal to false, and we will simply return a flag. So let's try to code that the elbow. So let's consider this as our solution function. In this we are getting root node, and this is our code. If root is null, simply we will return 0, as we are returning for the height of a tree. Root becomes null, so we will return 0. 0 is left height becomes solve for the left of the root, and for the r becomes solve for the right subtree, right node. Okay, now what we have to do, if L is the absolute difference between L and R is greater than 1. That means flag becomes, it means somewhere in the subtree, somewhere in the tree which has subtree, the difference between the its left subtree and right subtree has greater than 1, means it is somewhere in the tree. Is it not balanced? Okay, so becomes false, and we will continue returning the, as the we are returning maximum value of r comma l and plus 1, because plus 1 is the root node. or the self node for this. So this is our simple code for this. So let's see. So here I have written a new function solve and flag variable in the private section and solve function as well as in the private section of class. So if root is null, so we will simply return 0. If left, solving the left subtree and right subtree different, and then if absolute difference between left and right is greater than 1, simply we will flag becomes false and returning the maximum of left, right, and subtree. In this, we are simply returning the flag. If flag somewhere in the tree, if we are getting the difference between left and right subtree's height greater than 1, simply flag becomes false. And if there is whole the tree, all the binary tree is balanced, so never there will be any chance when flag becomes false. So that means flag becomes always true if there is a height balanced tree. So we have to simply return the flag. So let's compile and run program. Yeah, it's fine for the compilation and running. Now submit it. Yes, it runs successfully and get the test case all the all the test cases have passed. Thank you everyone for reaching out to this solution, and I hope you found it very helpful for your coding journey. And I hope you liked it. And if you liked it, click on the subscribe and like button for further videos. Thank you.